So uh, the topic of this video is distributed system and global state. Now, in this, we are going to address the problem which is associated with the collection or associated with the recording of the uh, different states, uh, different states of the different processes, because we have to maintain the all the states of the different processes globally in the distributed system. Of course, this is a challenging task to mm, to maintain a global state, because as we know that there is absence of global clock, as well as there is absence of shared memory. So how this will work, we will be discussing this issue in this. Now, as we know that the ordering of the message is a very important part of the distributed system. And as far as the global time ordering is concerned, it is based on the messages which is being received by different processes exactly in the order in which the message was sent. And that is why it is difficult to realize, it is very difficult to realize in the absence of the global clock that how it can be done that the message which has been sent earlier should be received as it is in the same order. And it is also very important, it's very difficult to synchronize the accuracy in between the different distributed processes. So uh, let us discuss what is the global state. Of course, the global state is the collection of all the local states of the processes, as well as the channels which are used for the communication. And we start this with an example whose illustration has been shown in this slide. Now, in this, we have two processes, A and B. Suppose and this is the global state in which the state of the individual processes as well as the state of these channels are being recorded. Now, uh, this particular figure shows that the stage of the computation when the 500, 550, 500 is being maintained by the account A, and 200 is the rupees dollar has been maintained by the B. So, and before we give this example, this has to be mentioned. It is important to mention over here that the channel is working on the FIFO basis, FIFO, that is first in, first out. The meaning thereby, the channels will be working in such a manner, whatever message is sent first will be received first, and the message which has been sent last should be received in the last. So now suppose that the state of the account A at the site S1 was recorded when the global state was at 1. Now assuming that the global state changes to 2, this is the global state 1, this is global state 2, and the state of the communication, that is state of the communication channels, that is C1 and C2, as well as the account of B, it is recorded when the global state in 2. Meaning thereby, when it is global, when it is in the global state 1, the state of the recording of the state of A is recorded, and in the global state 2, the status of B as well as the status of the channel which is being in communication, it is recorded. Then what will happen? And then when we going to composite all these two, all the states which was recorded, it should show that the A's balance is rupees 500 and the B's account is rupees 200, and a message in the transit, it is $50. So you can say that the extra amount, this is an extra amount which is appearing in the global state. Now, the reason for this is very simple, that before the information, the message has been sent, the state of A has been recorded. before the message was sent, as well as the channel state. As far as this channel state is concerned, it was recorded after the message is sent. So therefore, the recorded global state, this recorded global state is going to be inconsistent if n is less than n dash. Means the one value is less than another. And what is n? N is the number of the messages sent by A, the number of messages sent by A along the channel before the A state was recorded. N is the number of messages sent by A before the on the channel before the A state was recorded. And n dash is the number of the messages which is sent by A along the channel before the channel state was recorded. And that is why it is showing the inconsistency. So what will happen? Suppose the channel state was recorded when the channel state was recorded. This is the channel state and this is the state of the process. So suppose the channel state was recorded when the global state was 1, and A and B's state are recorded when the global state is at 2. Then the composite of A's state, B's state, and the channel state will show a deficit of $50. So it means that the recorded global state will be inconsistent if n is greater than n dash. So, so that is why for being a consistent state, it must be necessary that the n should be equal to n. Now, that is why it has been written here in the consistent global state. If the channel state is recorded when the global state was 1, and A and B's are recorded when the global state was 2, then the composite of A, B, and the channel state will show a deficit. This means that the recorded global state may be consistent if n is greater than n dash, and therefore consistent global state requires n should be equal to n dash. So this is the one of the fundamental point in which we have to maintain in such a manner that whenever we are taking the global state, all the states all together, when we are combining all the state of A, state of B, as well as the state of the channel. Because one time the state A is recorded, तो उस समय उसका status कुछ और था, and when it sends a message that to transfer $50, उस समय channel का state दूसरा था. तो अगर इसको हम composite way में लेंगे, इसको globally अगर हम देखने की कोशिश करेंगे, so it means the state of A, state of B, and the channel, it should be consistent if n is equal to n dash. Meaning thereby, n has sent a message to transfer $50. B has received that message and updated its value. So at that particular time, when the message which has been sent has been received by the receiving state or the receiving process, so at that particular moment of time, channel will be empty. So at that time, channel will be empty. But before that, A state was saying something, channel state was saying something, and B state was saying something. So at that time, it was not giving the consistent result. So that is why it is necessary that n should be equal to n dash for the consistent recording. Similarly, for the receiving point of view, the consistency will be m will be equal to m dash, where m is the number of the messages received along the channel before B state recording. B state की recording इससे पहले की, and m dash is the number of the message received along the channel, and m is the number of the message received along the channel by B before the channel's state was recorded. So it should be equal. M should be equal to m dash. And if m is equal to m dash, now if you go to the before that, it has been shown that n was greater than, if n is greater than n dash, then there will be inconsistency. So if n is greater than n dash, then naturally n dash will be greater than or equal to n. If n dash is greater than or equal to m, there is no system, as in no system, no message sent along the channel will, will be less than the receive. So if n dash is greater than or equal to m, so naturally n will be greater than or equal to m. So therefore, the consistent global state should satisfy that n should be greater than or equal to m. So how we are going to define this n should be greater than or equal to m is written here, that the state of communication channel in a consistent global state should be the sequence of messages sent along the channel before the sender's state was recorded, excluding the sequence of messages received along the channel before the receiver's state was recorded. Meaning thereby, this this state, global state, will be said to be consistent. And for it to be consistent, it is necessary that the sequence of the message which has been sent on the channel before the sender's state was recorded, इससे पहले कि sender state record किया जाए, the message should be sent. Excluding, उसमें इसको include नहीं करना है, that the sequence of the message received along the channel before the receiver state was recorded. So for global state, it is necessary that n should be equal to n dash, and n should be greater than or equal to n. So what is global state? And there are certain more things which we have to learn. As far as the local state is concerned, local state is represented by SI, and its local state of at a particular given time is defined by the local context, what is happening, whether it is remaining ideal or it is sending a message, whatever is that, it is being recorded locally. So that state is called local state. Send MIJ, what is the meaning of that? Send MIJ stands for message M is sent. It is an event. Sending of a message is an event, and it is happening in between SI to SJ. So it will be represented as send MIJ. Receive MIJ, it is again an event which is receiving a message M by SJ from SI. Time X will be the time of the event at a particular moment of time, that is X. Time send M, it denotes the time at which the event send M has occurred. Now, for a message MIJ sent by SI to SJ, SI is a process, SJ is another process, and SI is sending a message MIJ to SJ. So send MIJ will be in the local state, because this is an event which is occurring at LSI. So this send MI is in the LI, means the local state, if and only if the time of sending MIJ should be less than the time on which the state is being recorded. Similarly, receive MIJ will be in the local state of J process if and only if the time at which the message is being received is less than the time at which the state of J is being recorded. And transit, because we have to also capture, we also have to take care of the transit state also, meaning thereby the messages which is under the communication onto the channel. So transit LSI LSJ is also in a state which is showing the state of the channel, and it is a set of messages, that is MIJ, which is sent or the recorded at the local state I, and it is not received and not recorded at LSJ, the other state, the other process. Now, when it will be inconsistent, inconsistent means the two local state which is maintained at one point and another point, that is at LSI and LSJ, how it will be inconsistent. Set of the messages not sent or recorded at LSI, and it is received and recorded at LSJ. If it is so, if the message which has been sent by a particular process has not been recorded at the sending side, but it is being received at the receiving end and it is being recorded at the receiving end, then in that particular case, we say that these two states are in inconsistent position. And what is global state? Global state is a combination, it's a collection of all the local states of its sites. And what is consistent global state? Because global state is a collection of the local states. And this global state should be, it may be consistent, it may not be consistent. So what will be the definition of how we will say that the global state is consistent? Since global state is represented by all the local states, and it will be consistent if for all the values of I from 1 to n, where n is the number of processes, for all the values of I, inconsistent LSI LSJ is null. If there is no such thing that the message which has been sent has been received, if this is so, it's okay. If the message which has not been sent but it is received or recorded at the other process, then it will be inconsistent. So meaning thereby, if this particular set, the local set, the local state, LS, which is a combination of LSI, LSJ, is null, meaning thereby the message which has been sent, which is being received. ऐसा नहीं होना चाहिए कि message which has not been sent and it is still received. So it should be null. It should be fine. If it is so, then it will be called the global state. So a consistent global state. So therefore, in consistent global state, every received message, there should be a corresponding send event recorded in the global state. If there is so, that now you try to understand the point. Suppose a message has been sent by a sender, and this message is on the communication channel, and it is not received by receiver. It can be called as a consistent, because the time will come when it will be received. But it will be inconsistent if the message is sent by a sender, but it is not recorded in the sender's site, and it is being received by the receiver and recorded at the receiving point. Then it means there is inconsistency. This is the meaning of. So therefore, in inconsistent global state, there must be at least one message which will be receiving an event, and it is being recorded at the receiving end, but it is not sent and it is not recorded. Even though it has been sent, but it is not recorded. So whenever you send a message, it has to be recorded on the local state. And if it is not received by the receiver, there is no problem, because it is still in the channel, because channel state will be representing that there is a message which has been sent by the sender, and it will be received by the receiver. So in that case, it can be called as a consistent. But if the sender has sent a message, or there is an orphan message, if messenger has sent a message and it is not recorded at this local state, and it is being received by the receiver, then in that case, it will be inconsistent. Now the next is transitless global state. Transitless global state is also a combination of the different local state. It will be called transitless if and only if for all the values of I and j, which will be from 1 to n, the transit LSI LSJ is null, meaning thereby there is no message available on the channel. Whatever message has been sent, it has been received, and still the channel is showing empty and there is no message on the transit. So that is called the transitless global state. Now, we can go with an example. Now, this example shows the global state. So, global state can be taken anytime. Now, suppose there are two events which is happening in the state S1, LS11, LS12. There are three states which are three events happening in the S2, LS21, LS22, LS23, and three events at process S3. Now, process S2 has initiated a message which has been initiated an event, and it has been received by process S1. Okay. Process S1 has sent a message to the process S2, and process S2 has sent a message to the process S3. So at this particular moment of time, if we consider this moment of time. LS1, LS2, and LS3 is the time. It is not an event occurring, but it is the time when we are trying to find out the global state of the total system, of the distributed system, the meaning of that. So this is a curve has been shown here, which is showing that at this moment of time, we are trying to know about the local states of the individual process, and then trying to see whether these processes are in a consistent global state or not. So whenever we are talking about at this juncture of time, at this particular moment of time, the message has been received. At this moment of the time, message has been sent. At this moment of so whatever is the state of S1, it will show that it has received one message. Whatever is the state of S2 here, it will show that it has sent a message. And here there is no message. So its timing will be 0, 0, 0. So at this moment of time, at global state, that is a combination of LS1, LS21, and LS231, it shows that the global state is consistent because the message which has been sent has been received and it has been recorded. This is recorded and it is available here. This is received and it is available here. There is no message, so its state is empty. So in this particular stage, you can say the global state is consistent. Let us check about this. At this moment of time, process S1, one message has been received and one message has been sent. At this moment of time, message has been sent here and message has been received. And at this moment of time, process S3 is showing that message has been sent, but it is in the transit. So you can say that this global state which has been taken at this moment of time, which is shown by the dotted line, it is consistent. So this is consistent. This is consistent. Now let us check about this. The combination of LS11, LS22, and LS32. Now here, the state which has been recorded, whatever information in the form of a recording, this process S1 is having, that it has received one message. That's all. At this moment of time, this process S2 is showing that one message was sent and one message has been received. Now, this message which has been received, the sending event of this message has not been recorded in this. So when we take the global state like this, we will find inconsistency. Why? Because this sending event of the message is not recorded here. Of course, it may be recorded here, but here it is not recorded. So the time when we are trying to fetch the global state, it is showing that this is not recorded of sending event of the process S1, which has been received by process S2 at this moment. So whenever it is recorded at that particular time, it has recorded that this message has been received. So this is showing the inconsistent global state. So this is consistent, and this is inconsistent global state. Now you take another example. And before going to another example, let us check that what is called a strongly consistent global state. There are two kinds of global state. One is consistent global state, another is strongly consistent global state. In this is a global state which is consistent, I have said, and this is the global state which is consistent. But there is a difference in between this consistency and this consistency. And let us show it by example. But before going to the example, what is the meaning of strongly consistent? Strongly consistent includes that the global state should be consistent as well as it should be transitless, meaning thereby all the sending and the corresponding receiving events are recorded in all the local states of the processes, then only it is called the strongly consistent global state. And let us check with this example. We have three processes, P1, P2, P3. P1 has created an event, send a message to the P2. And at this moment of time, whenever we are trying to take care of the global state, the message has been sent, the message has been received, and there is no message in the transit. And the third state is ideal state. Third process is in ideal state. So this global state is said to be strongly consistent. Why it is strongly consistent? Because it is transitless also. There is nothing, its channel state is also saying that there is nothing in the channel. No message is pending. This is whenever we are trying to find out the global state at this moment of time, and we are saying that it is a consistent. How it is consistent? Now, at this moment of time, uh, one message has been sent, it's okay. At this moment of time, one message has been received, one message has been sent at this moment of time. So here the recording will be showing that the message has been sent. But whenever we are trying to find out the recording over here, the process P3, it has not received. It means the message which has been sent by the process P2, it is still in the transit. So it is a consistent, but it is simply consistent, and it is strongly consistent. And this is inconsistent. How it is inconsistent? Because at this moment of time, we have no recording of sending a message. And at this moment of time, it has been received. So at this time, the process P3 will be showing that it has received a message. And the message which has been received is not recorded as the sending event of the process P1. So that is why this is inconsistent. So we have a certain algorithm which is known as Candy-Lamport algorithm, which is applicable for the global state. What this algorithm says, it says that first of all, we have to assume that the channels which are used for the communication purpose, it works on FIFO basis, that is first in the first out basis. And according to this algorithm, every process will be using a marker to initiate the algorithm. Marker is nothing but it's a kind of a control message. It's a dummy message, and it has no effect on the function of the processes. So what is happening with the help of marker? Whenever the marker is sent by the process P, so what the process P will record its state. Whenever it is in the process of sending any message, whenever a process is in a position to send a message, before sending a message, it is necessary to send a marker and then record its state. For each outgoing channel, P sends a marker on the channel before P sends further message along the channel. Meaning thereby, before it sends the message, it has to send the marker. So it means marker will be followed by the message. Receiving marker, whenever another process is going to receive the marker, at that moment of time, if the receiving process has not recorded its state, अगर पहले से उसने अपने स्टेट को रिकॉर्ड नहीं किया है, तो वो क्या करेगा? पहले वो it will record the state of the channel as an empty sequence and send the marker, जैसे यहाँ पे बताया गया है. अगर उसने नहीं रिकॉर्ड किया है, तो it will try to record the state of the channel. और अगर उसने पहले से रिकॉर्ड कर रखा है, then if Q has already recorded the state before, then what it will do? It will record the state of channel as the sequence of messages received along the channel, and after the receiving state was recorded and before the Q has received the marker. Meaning thereby, before it is going to receive the marker, first of all, it has to update itself with the channel state as the sequence of the messages which is received through the channel, and after that, after after when the receiving state has already recorded it, and before the receiver state is going to receive the marker, meaning thereby इससे पहले कि वो किसी भी प्रोसेस के द्वारा भेजा गया मार्कर रिसीव करे, it will update its record by recording it's by updating its state by the information which is given by the channel, because channel may be possible that there will be a transit message and it has to be received by the receiver. So with the help of this Chandy-Lamport algorithm, we are able to we are able to maintain the consistency of the Chandy-Lamports as the consistent global state. Two more things which is very important part of this algorithm is that first we have to consider that the FIFO channel condition channel is working on the FIFO basis, as well as marker is also going to help us in satisfying the consistency condition, because marker is not being received by any process until unless it is going to update its record either by those messages which it has received, as well as by the channel information which is given, which is in the form of a message which is in the under the transit and has to be received by the receiver process. So the initiation of the marker can be done by any process, and its unique marker is the process ID as well as its sequence number. Now, the several processes can initiate the state recording by sending the marker, and concurrent sending of the marker is also allowed, but it will be received only one by the receiver. One possible way to collect the global state is that all processes send the recorded state information to the initiator of the marker, and the initiator process can sum up the global state. So this is a kind of a sequence which you can visualize with an example. Now, in this particular example, an algorithm has initiated when the system is in the global state SI, and it terminates when the system is in the global state SJ. Now, SC, there is another, it denotes the collection of the global state by the algorithm, and this SEQ denotes the sequence of the action which take the system from SI to SJ. So it means there exists a sequence SEQ dash also in this particular figure, which is showing a permutation of SEQ such that SC can be reached from SI by executing a prefix SEQ dash, and SJ and SJ can be reached from this SC can be reached SJ can be reached from SC by executing the rest of the actions of the sequence dash. So as far as the usefulness of the recorded global system is concerned, it lies in the ability to detect the stable properties. You might have gone through the operating system also, and the stable property is that you are starting any process and you are terminating any process. So it is also possible that there may be a situation in which the processes will be in the deadlock position. So if this stable property holds before the recording algorithm begins the execution, it continues to hold, as well as it will therefore include all the recording of the global system. So that is all about the global system, as well as how to maintain the consistency, how to implement the algorithm, that is Chandy-Lamport algorithm, to find out the causal ordering of the messages whenever it is being sent. At the same time, it is being in the sequence it is being received. So for maintaining the consistency, which is the very important issue related with the distributed system, can be taken care by maintaining the global state.